Very good morning, students. In the last class we are completing 10 objective questions on group 14 elements. Today we are completing remaining objective questions. Okay students, question number 11. Graphite conduct electricity due to following reasons. First one, highly delocalized nature of pi electrons, highly localized nature of pi electrons, highly polarized nature of pi electrons. Graphite is a good conductor of electricity due to presence of pi electrons, very clear. But the pi electrons are delocalized or localized or polarized. Always pi electrons are delocalizing in the layer structure of graphite. Due to this delocalization, the flow of electron takes place, hence graphite can act as good conductor of electricity. First one is correct answer student. That is highly delocalized nature of pi electrons. Highly delocalized nature of pi electrons. Next question student. Question number 12. Graphite cleaves easily between the layers. Thus it is soft and slippery in nature. Graphite cleaves between the two layers because graphite is soft in nature as well as slippery in nature. Next question student. The major difference between diamond and graphite is due to the diamond is having crystal structure whereas graphite is having layer structure. It is the difference between diamond and graphite. Second one, graphite combined with oxygen to form carbon dioxide where diamond does not. That is the wrong option student. Graphite and diamond allotropic form of carbon. Both react with oxygen, they can form carbon dioxide. Absolute correct that is. Next one is the atoms in each have different masses. The diamond and graphite contains only carbon. They are having similar masses. Therefore, the correct one is first one is the major difference between the diamond and graphite. One is having crystal structure, another one is having layer structure. If they are asking hybridization, that is also different. It is sp3 hybridization, it is sp2 hybridization. Okay students, right? A is correct answer. Question number 14. Which of the following molecule has a shape like soccer ball and called Buckminster fluoride? Here we know the student C60 having other names. C60 fluorine, buckyball, soccer ball, Buckminster fluorine. Not minister student, Minster, M-I-N-S-T-E-R. Minster, Buckminster fluorine. Okay. Next one. Question number 15. C60 is the only pure form of carbon. We know that the pure allotropic form of carbon is Buckminster fluorine, that is buckyball or C60. It is having 12 pentagons and 20 hexagons, 12 5-membered rings and 20 6-membered rings, 6-membered rings. Next one. Question number 16. The hybrid orbitals with 33.33% of carbon character are involved in the bonding of one of the crystalline allotropic form of carbon. We know the student there are three crystalline allotropic forms, that is diamond, graphite and fluorine. One of the crystalline allotropic form of carbon contains 33.33% of carbon, 33.33% of S character, 33.33% of S character, which is the crystalline allotropic form of carbon. Carbon black, graphite, diamond and gas carbon. Graphite is the correct answer because graphite can undergo sp2 hybridization. In graphite, the carbon atom undergo sp2 hybridization. Therefore, the percentage of S character is 33.33%. The percentage of P character is 66.66%. Therefore, the graphite allotropic is the correct answer. The way of asking question is brilliant student, very excellent manner they are asking. The hybrid orbitals with 33.33% of carbon. Indirectly they are given percentage of S character, that is sp2 hybridization. sp2 hybridization is present in graphite only. Here fluorine they are given, then both answers are correct. Here fluorine they are not given. Diamond is sp3, 25% S character. Gas carbon and carbon black, those are amorphous allotropic form of carbon. Those are not correct answer because crystalline allotropic form of carbon clearly they are mentioned. Therefore, graphite is the correct answer. Graphite is the correct answer. Next one, the mixture of CO and hydrogen. The mixture of CO and hydrogen are known as water gas, syngas and blue gas. Clear student? The mixture of CO and hydrogen is known as water gas, and it is known as syngas because this CO and H2 can be used for the synthesis of the methyl alcohol or methanol. Hence it is known as syngas because it is used for the synthesis of the methanol. CO plus 2H2 gives rise to CH3OH. And this CO plus H2 are also known as blue gas because it can bond with the blue flame. It can bond with the blue flame. Total 3 other names student. Water gas, syngas, blue gas, CO plus H2. CO plus H2. Next question student. Question number 18. Sorry. Question number 18. The mixture of CO and nitrogen, the mixture of carbon monoxide and nitrogen is known as producer gas. Is known as producer gas. And the mixture of CO plus H2 plus N2 are known as semi-water gas. Are known as semi-water gas. In these 3 gases, in examination point of view, one is expected student. CO plus H2 plus N2 semi-water gas. CO plus N2 producer gas. Carbon monoxide plus hydrogen water gas. Okay student. Next question. Question number 16. Sorry. Question number 19. Main reason of human death due to carbon monoxide poisoning is due to. Main reason of human death due to carbon monoxide poisoning is. Generally student, when you are inhaling carbon monoxide, that can combine with hemoglobin to form carboxyhemoglobin, which is 300 times more stable than the oxyhemoglobin. 300 times more stable than the oxyhemoglobin. Hence what happens student, here carboxyhemoglobin will be more stable than the oxyhemoglobin. More stable than the oxyhemoglobin. Due to this reason, the carboxyhemoglobin prevent the binding capacity of oxygen with the hemoglobin. Hence, the oxygen supply to the different parts of the human body is not possible. Hence, the human being directly leads to death only. When hemoglobin combines with oxygen to form carboxyhemoglobin, which is 300 times more than that of oxyhemoglobin. 300 times more than that of oxyhemoglobin. Due to more stability of carboxyhemoglobin, this carbon monoxide prevents the combining capacity of oxygen with hemoglobin. Hence, oxygen does not combine with hemoglobin, does not transport to the different parts of the human body. Hence, the human directly leads to death only. Okay, students, small technical problem. Now it is solved. Question number 20, students. Question number 20. H2CO3/HCO3 minus buffer system helps to maintain pH of the blood between 7.26 to 7.42, 3.26 to 7.42, 7.26 to 8.00, 7.4 to 7.96. We know that the pH of the human blood is basic in nature because it is 7.26 to 7.42, which is maintained between these two values only. The pH of the blood is maintained constantly because of acidic buffer system, that is H2CO3 plus HCO3 minus. We know that the buffer solution which resists the change in pH value by the addition of small amount of strong acid or strong base are known as the buffer solution. Due to acidic buffer system, the pH of the human blood is always constant, that is 7.26 to 7.42. Clear students? Right. Next question number 21. The structure of the compound obtained by a chemical reaction of silica with fluoride of hydrogen. When silica SiO2 react with hydrogen fluoride, it can form silicon tetrafluoride plus water molecule. Here the structure of silicon tetrafluoride is tetrahedral with sp3 hybridization and a bond angle 109 degrees 28 minutes. It is having a tetrahedral structure. Silicon tetrafluoride is having a tetrahedral structure with sp3 hybridization and a bond angle 109 degrees 28 minutes. Next question student. Question number 22. Which of the following is extensively used as piezoelectric material? It is used in making clocks in modern ratio, television, broadcasting and mobile radio telecasting. Quartz student. Quartz clocks, piezoelectric material. So many times we are discussing. Quartz can be used as piezoelectric material, accurate clocks, televisions and the transistors and radios. We are using the quartz material. That is form of silica or silicon. Next one, student. Question number 23. Question number 23. Which of these is not a monomer for high molecular mass silicon polymer? High molecular mass silicon polymer. First one is trichloromethylsilane, dichloromethylsilane, trimethylchlorosilane, trichlorphenylsilane. The correct answer is C is the correct answer, student. That is trimethylchlorosilane. Trimethylchlorosilane cannot use it for making high molecular weight silicon polymer. High molecular weight silicon polymer. Because here only one hydroxy group is present due to presence of one chlorine atom. Hence, trimethylchlorosilane cannot use it for making a high molecular mass silicon polymer. Whereas dichloromethylsilane, trichloromethylsilane are can use it for making high molecular mass polymer. Clear, student? Therefore, it cannot use for making high molecular mass polymer. For example, Me2SiCl2. Similarly, MeSiCl3. Here, trimethylchlorosilane cannot use, whereas dichloromethylsilane can be used. Trichloromethylsilane can be used. This is only cannot be used for making a high molecular mass silicon polymers. Very important, student. Next one. Question number 24. Hydrolysis of dimethyl dichlorosilane followed by condensation polymerization leads to polymerization. In theory, already we have discussed, student. Dichloromethylsilane upon hydrolysis it can form dihydroxydimethylsilane, which is upon condensation polymerization to form straight chain silicon polymer. Straight chain silicon polymer. The correct answer is A is the correct answer. Straight chain silicon polymer is formed. Question number 25. Name the type of structure of silicate in which one oxygen atom of SiO4-4 is shared. We know, student, yesterday we were discussing a classification of silicate. Ortho, pyro, two-dimensional sheet silicate, three-dimensional network silicate, chain silicate and cyclic silicates. In case of ortho silicate, 0 oxygen atoms or no oxygen atom sharing between two silicate units. Whereas in pyro silicate, only one oxygen atom sharing between two oxygen atom. One oxygen atom sharing between the two silicate units. Therefore, pyro silicate, one oxygen atom is shared. Here they are clearly asking, in which of the following silicates two oxygen atoms are sharing? In which of the following silicates one oxygen atom is sharing between the two silicate? One oxygen atom is pyro. 0 oxygen atom is sharing, that is ortho silicate. Therefore, our answer is pyro silicate. Our answer will be pyro silicate. Once you can verify the previous video, student, that is video number 10. Clearly, we are discussing that silicates. Next one, student. Question number 26. Which of the following is used to convert alcohol to petroleum directly? Alcohols can be converted to petroleum or gasoline by using one zeolite that is known as ZSM5. The full form is zeolite sieve of molecular porosity 5. Zeolite sieve of molecular porosity 5 is the full form of ZSM5. Copy this, student. Next continuation, students. Question number 27. Question number 27. The incorrect statement related to the elements of 14th A group. The incorrect statement. First one, student. The electronegativity of silicon and germanium is same. The electronegativity of silicon and germanium will be same. The experimental values of electronegativity values of group 14 elements is carbon 2.5, silicon 1.8, germanium 1.8, tin 1.8 and lead is 1.9. Here silicon and germanium are having same electronegativity. That is the correct statement, students. Okay. Next one. The density of silicon is least. Let us observe the density of the group 14 elements. Carbon is 3.5, silicon 2.3, germanium 5.3 and tin is 7.2 and lead is 11.3. It is the density order. Among group 14 elements, the density of the the element having least density will be silicon. The element having least density will be silicon. Hence, the density order of the group 14 elements will be like this, students. First one is silicon, next one is carbon, next germanium, next tin, the last one is lead. The last one is lead. Therefore, the element having least density will be silicon. Least density will be silicon. While explaining theory, I am giving different order, student. Once you can rectify that mistake. Okay, silicon is having least density. Next one, student. The carbon has higher first ionization potential. We know that the ionization potential of the group 40 elements decreases from carbon to lead. Decreases from carbon to lead. But some exception is there. The ionization enthalpy of lead is more than that of tin. Because of poor screening effect of the completely filled d and f orbitals present in the lead. Clear, student? Next one. Carbon has the highest ionization potential. Therefore, the statement will be correct. Next, fourth student. Lead has lowest first ionization potential. But lead is not having lowest. When compared to tin, it is having highest ionization potential. Lead is not the element having lowest ionization potential. Lead is having highest ionization potential than tin. Therefore, here the fourth option is the wrong option. Okay. Silicon, germanium have the same electronegativity, and silicon is having lowest density in the group 14 elements, and lead is having the lowest ionization. Lead is not having lowest ionization element, and carbon is having the highest ionization element in the group 14 elements. These are experimental values, students. These values are very much helpful to you. Next one, question number 28. The difference in the properties of CH4 and SiH4 is due to large difference in the electronegativity of carbon and silicon, student. Here CH4 is known as methane, SiH4 is known as silane. Methane and silane different in the properties. Difference in the properties, even though they are belongs to same group. The hydrides, these two compounds are hydrides of group 14 elements, even though they are belongs to same group. But methane and silane properties are different. Because the reason is large difference in the electronegativity of carbon and silicon. Here carbon is having electronegativity 2.5, whereas silicon is 1.5. Due to difference in this En values, they difference in their properties. Next question. When lead react with the dilute nitric acid, what is the product from? Very important, student. Every year repeated question. What are the products formed when lead react with the dilute nitric acid? Here, when lead react with dilute nitric acid, it can form lead nitrate PbNO3 taken twice plus nitric oxide NO plus water molecule. Lead nitrate plus nitric oxide plus water molecule can be formed. Next question, student. Consider the following oxide: germanium oxide, carbon dioxide, carbon monoxide, germanium dioxide, silicon dioxide, tin monoxide. Consider the following. Which of the following options is correct, student? Acidic, amphoteric, neutral, and basic. Different types of oxides they are given, student. We know that carbon dioxide, silicon dioxide, germanium oxides are acidic in nature. Reaction with oxygen we will discuss, student. Carbon dioxide, silicon dioxide, and germanium dioxides are acidic in nature. Whereas carbon monoxide is neutral oxide, neither react with acids nor react with the bases. And tin dioxide, tin monoxides are amphoteric oxide. They can react with either acids or bases, both acids and bases. Tin dioxides and tin monoxides are amphoteric oxides. Okay, next one. Question number 31. Next question. Graphite used as lubricant. Graphite has layer lattice structure and the attractive forces between the layers will be weak. Here, student, both here in the NEET model, this type of question, assertion and reason type. They will give one statement. For the following statement, they will give the reason. The reason is the correct explanation of A. A is the correct answer. A and reason is correct and reason is not correct. Correct explanation of A. B is correct. A is correct and B is false. C is correct and A is false. B is true. D option will be correct. Here these type of questions are assertion reason type question. Assertion reason type question. Assertion means statement, reason means the following reason for the particular statement. For example, graphite used as lubricant. The statement is correct statement, student. Graphite used as lubricant. Next one. Graphite has layer lattice structure and attractive forces between the layers will be weak. Graphite has layer structure between the layers, weak van der Waals forces are present. Both statements are correct. And the second statement is the correct reason for the first statement. Graphite has lubricant because graphite has layer structure and weak van der Waals forces are present between the layers. Two statements are correct and second statement is the correct explanation of the first statement because graphite has excess lubricant because graphite is having layer structure. Graphite is having layer structure and weak van der Waals forces are present between the layers. Therefore, A is the correct of student. Next, similarly, question number 32 student is. Next question. Diamond is very hard element. Diamond is very hard element. That is the correct statement. Diamond has giant three-dimensional network structure and CC bond will be very strong. It is both statements are correct and second statement is the correct explanation of E. Diamond is hardest substance, one of the hardest substance in nature because it is having crystal lattice structure and CC bond will be very strong and the carbon-carbon bond will be very strong and highest bond energy and more energy is required to break the CC bond. Therefore, A is the correct option, student. Next question, very important, give the star mark, student. In Atkinson process, this process can be used for the manufacture of graphite, student, for the manufacture of the graphite. Hence, this process is known as Graphite-Atkinson process. Graphite-Atkinson process. In Atkinson process, A is heated with silica, that is SiO2, in an electrical furnace at a temperature 3700 Kelvin to obtain an intermediate B, and finally to give C and D. D goes out as vapor. D goes out as a vapor. Then A is an element, B is oxide, B is an oxide, C is an element, A, C are allotropes and B, C are allotropes. And B, C are allotropes. Here, student, first one. Here A is carbon black, one of the allotropic form of carbon. React with silica at a temperature 3700 Kelvin. It can form silicon carbide, and carbon monoxide. When B is heated, it can form silica and carbon graphite. Silicon and carbon graphite. Therefore, here A, C are allotropes is the correct statement. A, C are. Carbon black is amorphous allotropic form of carbon and carbon graphite is crystalline allotropic form of carbon. Here is first of student, A is an element, B is oxide, B is not oxide, B is the silicon carbide. Next, C option is correct option, student. Next one, B, C are allotropes. B, C are not allotropes. B is silicon carbide and C is only allotropes. Therefore, student, B is an oxide. C is an element. That is also wrong option. Therefore, only C option is correct. A, C are allotropes. This process is known as Graphite-Atkinson process. Atkinson is the name of the scientist, student. Atkinson manufactured the graphite by using this process. Once again, carbon black is heated with silica at a temperature 3700 Kelvin. It can form silicon carbide plus carbon monoxide. Silicon carbide is heated, it can form silicon and carbon graphite. Here A, C are allotropic form of carbon. C option is the correct. A is amorphous allotropic form of carbon and C is crystalline allotropic form of carbon, that is graphite. So students, next one. Next question. An acidic flux among the following. SiO2 react with calcium oxide, can form calcium silicate, CaSiO3. Generally, here flux means the substance that can be used to remove the impurities are known as a flux. If it is having acidic nature, acidic flux. If it is having basic nature, basic flux. The flux that can be used to remove basic impurities are known as acidic flux. The flux that can be used to remove acidic impurities are known as basic flux. Acidic flux can use it to remove basic impurities. Basic flux can use it to remove acidic impurity. Here students, here silicon dioxide can act as acidic flux. Why? Because when silica combined with calcium oxide, that is basic nature compound to form calcium silicate. Therefore, the correct answer is an acidic flux among the following is silicon dioxide. Next one, student. Next question. When silicon tetrachloride combined with water to form product X and HCl, X on heating up to 1000 degrees centigrade, Y is obtained. Y on heating with excess of hydrofluoric acid, the final product obtained is H2SiO3, H4SiO4, SiO4 and H2SiF6. D is the correct option, student. Because when silicon tetrachloride reacts with water or upon hydrolysis to form X plus HCl. Here X is known as silicic acid, tetrahydroxysilane or silicic acid, which is upon heated at 1000 degrees centigrade, it can form silicon dioxide, that is Y, that is silicon dioxide, that is Y, which can react with excess of fluorine, it can form H2SiF6 can be formed. The final product will be H2SiF6. Therefore, D is the correct option. Copy this, student. Okay, next continuation, students. The question number 36 we are discussing. Silica SiO2 react with A to form X and Y. In this reaction, Y is one of the global warming gases, that is greenhouse effect gases. A is the water soluble alkali metal carbonate whose molecular weight is 106. That is sodium carbonate, student. Sodium carbonate is having 106 molecular weight. The common name of X is, that is indirectly X they are given sodium carbonate. Therefore, silica react with the sodium carbonate, it can form sodium silicate Na2SiO3 plus carbon dioxide. Here Y is carbon dioxide, which is known as global warming gases or greenhouse effect gases. And this sodium silicate commercially known as water glass or liquid glass. Once again, student, silica combined with A to form X and Y. Y is the global warming gases. Here the A is soluble alkali metal carbonate whose molecular weight is 106. The molecular weight of sodium carbonate is 106. Okay, student. Next one. Silica SiO2 is a solid, whereas carbon dioxide is gas, because silica SiO2 is a three-dimensional network solid. It is not the discrete molecule, it is not the monomer. In silica SiO2, each silicon atom can be bonded to 4 other oxygen atoms, and each oxygen atom can be bonded to 2 silicon atoms to form a giant three-dimensional network structure. Hence, it is hard in nature. Next one, student. Whereas the carbon dioxide is a discrete molecule. The carbon dioxide cannot bond it to the different CO2 molecules. It is a monomer and it can exist as a separate or a discrete molecule. Therefore, due to this reason, silica is a solid, carbon dioxide is a gas. Even though both are oxides of carbon and silicon. Next one, student. Zeolites are used as ion exchanges and molecular sieves. We know the students zeolite conceptually. Zeolites are used as ion exchanges to exchange the ion. Next statement, student. Zeolite consist cavities of different sizes, can trap the calcium plus 2 ions from hot water and also molecules like ammonia and carbon dioxide. Very important reaction, student. In the hydrogen chapter, in the hardness of water topic we are discussing, the calcium plus 2 ions present in the hot water can be removed or replaced by using zeolite. When a sodium zeolite reacts with the hot water, the calcium plus 2 ions present in the hot water replaces with sodium. That is, calcium zeolite can be formed plus 2 moles of Na plus can be formed. Here the calcium plus 2 ions can be formed as a precipitate, they can be removed by filtration. Here what happens, student? Exchange of ions takes place. That is, calcium ion exchanges with the sodium ion. That is known as exchange of ions. Therefore, zeolites can participate in exchange reactions, exchange of ions, and this reaction can be used to remove hardness of water. A is correct, student. Both statements are correct, and second statement is the correct explanation of first statement. A is the correct option. Next question, student. Question number 39. When sum of silicon plus 4 in the framework silicates are replaced by Al plus 3 and an additional metal ion, it results in the formation of zeolites. We know the students, in zeolites, the compound which are obtained by the replacement of one or more silicon atoms with aluminum plus 3 are known as zeolites. The zeolites are having negative charge. The negative charge can be compensated by using Na plus, calcium plus 2 and Mg plus 2 ions. Already we are discussing. Once again, recall that information, student. The compounds which are obtained by replacing one or more silicon plus 4 ions with the Al plus 3 ions are known as zeolites. Zeolites are having negative charge. The negative charge compensated by using the positive ions like Na plus, K plus and Mg plus 2 and calcium plus 2. Okay, students. Next one. Last question, student. Question number 40. In so many times this question is given. Choose the correct option regarding A and B from the following. Silica can react with acid hydrofluoric acid, base sodium hydroxide to form B and A. What are the products B and A? We have to determine. Silica does not react with acids, bases, oxidation and alkalis except two substances in the nature. Those are hydrofluoric acid and sodium hydroxide. Silica reacting with hydrofluoric acid, it can form silica tetrafluoride plus water molecule. Hence here B is silicon tetrafluoride. When silica acidic in nature react with the bases like sodium hydroxide to form sodium silicate plus water molecule. The sodium silicate can be also known as water glass or liquid glass. Here the common product is water molecule. They are present in a 1:2 ratio. 1 molecule of water and 2 molecules of the water. Here our question is what are A and B? A is Na2SiO3 and B is SiO4. With this, the classwork questions are completed, student. In homework questions, you can discuss that. Only one homework question you can feel difficulty, that I will discuss. What is the covalency of silicon in H2SiO6? The covalency of silicon will be 6. Why? Because, student, this compound appears as silicon bonded to 6 plus to 8 atoms, but the maximum covalency of silicon will be 6. It does not exceed 6. Hence, in H2SiO6, the covalency of silicon will be 6 only, but not 8. Okay, student, with this, the classwork questions are completed. The homework questions, you can solve your level best. All questions are easy questions only. With this, the group 14 chapter will be completed. All the videos you can observe, student, nearly 12 videos from introduction neatly we are discussing. With these videos, you can solve some objective questions in different books also. Okay, students, right? All the best.